Alright, here's our video on angle of depression. And similar to angle of elevation, obviously now, instead of looking up, we're basically looking down. There is one major point of contention with angle of depression that I think people get confused with, and that's really the biggest reason for this video. Obviously, when you look at angle of elevation problems, it's when you're looking up, and then angle of depression, obviously we're going to be looking down. So, for an example, if you're standing on the roof of a building, so here would be the roof, standing on the roof of the building, you'd be up here, and you spot someone at a distance of 60 feet from the base of the building. So here's the base of the building, and 60 feet away would be right here. The angle of depression is here. The angle of depression is never here. It's always here, because it's the same idea as the angle of elevation is. If I were looking straight ahead, I'd be looking out this way, and then this line down here creates that angle of depression right here. Now, if you notice with this dotted line, it's parallel to this line. So therefore, we have alternate interior angles. Therefore, angle of depression is always equal to angle of elevation. So to make our lives simpler, we're going to label the triangle the same way we label angle of elevation. Our height or altitude is here, our distance on the ground is here, and our exact distance from like the person on top of the roof to the person on the ground would be the hypotenuse. The big thing that people get confused with is, as weird as it sounds, you have to put the angle of depression literally where you put the angle of elevation to solve your problems. Remember, we're just creating a picture to help us solve a problem. So it would be most beneficial to have the angle of depression down here. Now, once again, it is of utmost importance, I know I'm repeating myself, but it's of utmost importance, the angle of elevation goes here. It never goes here, it always goes here. And then from there, we have our example problems. A pilot spots a person on the ground exactly 10,000 feet from the plane. Well, 10,000 feet from a plane is right here. It's the hypotenuse. And they give that angle of depression of 37, which I'm going to put right here. My altitude is my x, and then I do my trig work. In this case, we're going to use sine. Be a sine of 37 equals x over 10,000, and then we use our basic trig functions. Here, a person on the roof of a building, 80 feet tall right here, spots a person 100 feet away from the base of the building. They're not 100 feet from the person, they're 100 feet away from the base of that building. And now I use an inverse tangent to find my angle of depression. And once again, angle of depression goes here because it's equal to angle of elevation. Fighter pilot spots a target at an angle of depression of 19 degrees, so I put it right here, while flying at an altitude of 15,000 feet. Remember, altitude is straight up and down, and I want to know how far we are from the target. And that's how I would judge the distance to the target, is the hypotenuse. So sine of 19 equals 15,000. We multiply x on both sides, and then divide 15,000 by sine of 19. And we got our 46,073 as our answer. And then finally, a helicopter is 1,000 feet from the landing pad with an angle of depression of 58 degrees. I put it right here. How far is the landing pad from the helicopter, or from the spot directly under the helicopter? Well, it's 1,000 feet from the landing spot with an angle of depression of 58 degrees, so we're looking out this way. So that exact distance is a hypotenuse, and I'm looking for the distance from the pad to a spot directly under the helicopter, which is basically on the ground, which means we're finding this distance here, and therefore we're going to use cosine. The cosine of 58 is equal to adjacent, which is x, over hypotenuse, which is 1,000. We multiply the cosine of 58 by 1,000, and we get 529 and 92. All right, guys, good luck with the assignment.